Hi everyone. In today's lesson, we are going to begin our study of trigonometry. Now, trigonometry is just the Greek word for triangle measurement, or the study of the relationship between the sides and angles in a triangle. Now, in total, there are 6 different trigonometric functions, and they are sine, cosine, tangent, secant, cosecant, and cotangent. Now in geometry, our focus is on the first 3, sine, cosine, and tangent. And so today's lesson is all about the tangent ratio in a triangle. Okay, so the tangent ratio of angle A in our diagram is the relationship between the side opposite to angle A and the side adjacent to angle A. Now, if you take a look in our triangle, and I've marked off angle A, if you go all the way across the triangle, this leg of the triangle, we would say, is the opposite leg to angle A. And this leg, the other part, the other side of our right angle, is referred to as the adjacent leg. Remember that the legs are the 2 sides that make up the right angle in a right triangle. So if you go across the triangle, that's the opposite leg. If you're using the segment or the leg that forms one side of your angle, that's the adjacent leg. So the tangent ratio of angle A is equal to the leg opposite angle A. So that's the length of it. So leg opposite angle A divided by the length of the leg adjacent to angle A. Okay, so we can say that the tangent is equal to opposite over adjacent. So we can shorten that to just OPP over ADJ, and that's what we're going to see from now on, opposite over adjacent. So take a look at our first example. In example 1, we have to find the tan of angle A. By the way, that's the abbreviation for tangent, is just TAN. The tangent of angle A. We also have to find the tangent of angle C. Well, first of all, notice where angle A is. And for angle A, 7 is the opposite leg, and AB over here is the adjacent leg. But we aren't given the length of it. So the first order of business would be to find the length of that leg. Well, you could use the Pythagorean theorem, but you all have been working on memorizing your Pythagorean triples. So you have 7, blank, 25. So if you know your triples, you can quickly find that this leg should be 24. So for the tangent of angle A, we want to use that opposite leg, which is 7. And we want to divide it by the length of the adjacent leg, which is 24. So tangent of angle A is 7 over 24. Now check this out. I'm going to take and highlight angle C with blue. Now angle C is in this lower left-hand corner. Now when we're talking about angle C, 7 is no longer the opposite leg, and 24 is no longer the adjacent leg. So I'm going to erase that. For angle C now, because we're changing our angle, we have to change our perspectives. Angle C, the opposite leg, is 24. And 7 is now the adjacent leg. So notice that the tangent of angle C, instead of being 7 over 24, will be 24 over 7. Now, the tangent of an angle, again, is the comparison of 2 sides, the ratio of 2 sides, and it's dependent on the size of the angle and not the size of the triangle, and we'll come back to that in a little bit. Okay, for example, in this diagram, we have to compare the tangent of angle A to the tangent of angle D. So in our triangle on the left, here's angle A. 4 is the opposite leg. 3 is the adjacent leg. So the tangent of angle A be equal to 4 over 3. Opposite over adjacent. Let's check out angle D. Angle D, right here, has a leg opposite it of length 8. And 6 is the adjacent leg. So the tangent of angle D would be equal to 8 over 6, which also reduces to 4 over 3. Okay, so notice that the two triangles are different sizes, but the tangent of angle A and the tangent of angle D are both equal to each other. They're both equal to 4/3. That proves that angle A and angle D are congruent. But we can also figure this out because we know that the two triangles are similar to each other by the side similarity. We have side lengths of 3, 4, 5. They've been multiplied by 2 to create this triangle 6, 8, 10. So the two triangles are similar to each other, therefore corresponding angles are congruent. Therefore, the corresponding angles have to have the same tangent value. Okay, there are lots of different ways to calculate a trig value. For example, you can read a trig table, and if you have a book handy, flip to page 311, and you'll see a giant table. Back in the day when I was in high school, this is all we had. We weren't allowed to use calculators. We only had the trig table to work with. Now the trig table in your book rounds each value to 4 decimal places, with a few exceptions in there, of course. When you have to use a trig table, or if you have to use a trig table, you need to use all 4 decimal places if you're multiplying it by another value. Okay, so reading your trig table, if you go to the column where it says tangent, so you're going to follow that down the page, but look to the left-hand side for the angle measure of 45 degrees, and kind of like follow along horizontally and vertically until you find a match. And the tangent of 45 degrees should be 1. That's what you should see in the table. Okay, likewise, if you look up 30 degrees, so find 30 degrees on the left-hand side, and then move to the right until you find the tangent column, and in there you should see the decimal 0.5774. Okay, finally try a tangent of 73 degrees. So find 73 degrees in your table, work to the right, and the tangent of 73 is 3.2709. Okay, now working in reverse. Okay, this would be doing the inverse tangent. Okay, so what I'm asking you here is what angle has a tangent value equal to 1.7321? So go under the tangent column and keep scrolling down until you find that decimal, and then look to the left, and you should see that the angle measure is 60 degrees. Okay, on your calculator, now this is using one of the calculators in the classroom. Make sure the calculator is set to degree mode, meaning on your screen you should see a little DEG. If not, then you have to find the key on the calculator. I don't have one in front of me, so it's a little tricky, but it'll say like RAD or RD and DRG or DEG for degree. You have to make sure you press that key until you change it to degree mode. It should come up. If you press that key, it comes up with a menu, and you should be able to use the arrows to highlight DEG. So on your calculator, you would hit the tan key. That's for tangent. Type in 1, hit enter or equals, and it should come back. Sorry, tangent of 45. Let's do that one. If you press tangent and then 45, as long as you're in degree mode, it should come back with 1. Try tangent of 30. Again, this is on the blue calculator in the classroom. When you hit enter, it's going to give you a much longer decimal. It's going to keep going on and on forever and ever. So your calculator is a little more precise than using the trig table in your textbook, because it'll have the sine, cosine, and tangent figured out to many, many places. Alright, finally, if you're going to use your phone, if you have a smartphone and you want to use the calculator on the smartphone, you're going to have to wait for more specific instructions from me. So we'll do that in class later this week. Okay, the point of this exercise is just to show you that every angle measure has a distinct value for its sine, cosine, and tangent. Okay, so you could type in like the tangent of 13.2895 degrees and it'll come back with a number for you. Okay, so it's like there's a giant table stored in your calculator. Alright, so trig is probably one of the most useful things in the real world that you'll learn in geometry, other than possibly Pythagorean theorem and area and volume. Alright, so trig can be used to calculate distances, whether it's through navigation or just on a map or just in real life. It can help you calculate like the height of an object that otherwise would be really difficult to measure. There are just a whole lot of different applications. Alright, but before we get to an application, let's take a look at how to use it to solve for a side in a triangle. So first of all, you need to identify an angle that you want to work with. Now in here, the 24 degrees is marked for us, so we'll try to use that one. And then identify your sides as either being opposite, adjacent, or the hypotenuse. Now, for tangent, we don't need the hypotenuse. So this side is the hypotenuse, but we don't really care about it because tangent, if you recall, is the ratio of the opposite leg to the adjacent leg. Okay? So for where the 24 degrees is placed in our picture, the side marked with X is the opposite leg, and the side marked with 25 is the adjacent leg. So that means that we can write this equation, the tangent of 24 is equal to X over 25. Now think about this. We have to solve for X. We have to get X alone. So because X is being divided by 25, we're going to take and multiply both sides by 25. But another way to think about it is just to put tangent of 24 over 1 and think about it as a proportion. And we can cross multiply. So X times 1 gives us X. And then we're going to set that equal to 25 times the tangent of 24. Okay, now it's time to go to your calculator. Now, if you're working with the blue calculator in the classroom, which is what I recommend because using your phone is going to be trickier, I want you to just type it in as you see it. 25, tangent, 24, and then hit enter. And when you do so, it should come back with a decimal, and the directions say round to the nearest tenth. So we're going to round it to 11.1. Final answer. Okay, last one, and this is a real world example. This is find the angle that the road makes with the horizontal if its grade is 4%. So first of all, this is our road. Okay, the grade is the steepness of the road. So 4% would be 4 out of 100, like that, or 0.04, depending on how you want to write it. Okay, the grade of the road, by definition, is equal to the slope, which is often considered to be rise over run. Okay, so the rise would be the vertical distance it increases by, and the run would be the horizontal distance. So if we say that the grade of this road is 4%, that means that the road is rising 4 feet vertically for every 100 feet it is going horizontally. Okay, so notice that the rise is our opposite leg to our angle, and our run is the adjacent leg to the angle. So we can come up with a trig equation that involves tangent. So you can say the tangent of our angle x, we always have to have an angle in here after tangent, and we don't know what the angle measure is, so that's why the x is there. So tangent of x is equal to 4 over 100. Now, this is a different situation than we had on example 2. In this example, cross multiplying won't help us. Actually, it'll make things worse. Okay. So remember earlier when we used the trig table, I mentioned doing a reverse lookup. That's kind of what's going to happen here. Okay, so first, rewrite this as the tangent of x is equal to 0.04. And I just spotted a typo because it should be 4 over 100, not x over 100. Okay, so we have our tangent of x is 0.04. So you could try using the trig table in your textbook, but it's not going to be as exact as we want it because we're going to round to, well, it says to the nearest degree, but we're going to go a little bit more specific than that. Okay, so when we do a reverse lookup, when we're looking for the angle measure and we know the tangent, to tell the calculator to do that, we have to do something called the inverse tangent. And it looks like this, tan negative 1. So on your calculator, what you would do is press second, the blue second key, and then tangent. And then it should come up with tan negative 1 on your screen. Okay? Now this is again referred to as the inverse tangent. But we'll probably use it more so often that you might even just call it second tangent. Okay? So when you type this into your calculator, again, you have second tangent to give you tangent negative 1, and then you have to tell the calculator what the tangent value is, and then what it's going to do is it's going to go to the table and do the reverse lookup. It's going to look for 0.04 under the tangent column, and it's going to come back with an angle measure. And I have 2.29 degrees, or approximately 2 degrees if we round to the nearest whole degree. Okay, good luck on the homework, and know that over the next couple days we're going to be doing lots of practice together. I will answer every single one of your questions, and I know it's brand new material, but I think that you'll get it with practice.